Hello. So great to see everybody. Welcome everyone here in person. I'm Mark Etkine. I'm the CEO of the Computer History Museum, and I just want to welcome everyone in person, welcome everyone online, and a special shout out to all our members who attended our reception. Now, many of you know this, Taiwan is the world leading producer of semiconductors, and they are the second largest exporter of computers. And here at CHM, we have been tracing the rise of Taiwan for 20, 30 years. In 2007, we had on our stage Morris Chang. Many of you may know Morris. He started TSMC, which was the world's first semiconductor foundry, and now the most successful and largest Taiwan tech company. Doing the interview with Morris was an engineer from Silicon Valley who had recently started his own chip company specializing in graphic chips. You may know that company, NVIDIA. You may know the person who was doing the interview, Jensen Huang. And since 2007, we have been collecting Taiwanese computer history. We have hardware, we have software, we have archives, we have oral histories. And we use this collection in our exhibits to decode the past, understand the present, and inspire the future. Our hope is that when young people come to our museum, they want to be engineers, they want to be entrepreneurs, they want to be innovators, they want to be the next Morris Chang, they want to be the next Jensen Huang. We also use this collection, we make it available to researchers. They can go to our Schustek Research Archives, and they can also see many of our archives online. And I'm proud to say that our archives, our oral histories, were used for tonight's book. Honghong Tinn used our archives, and they informed this remarkable book. And with that, I'd like to introduce tonight's moderator. He's one of our rock star curators. He was an Apple engineer, and he specializes in software history. Please welcome Hansen Su.
Thank you, everybody. So I want to introduce Honghong Tinn. I have the distinct pleasure of introducing the author of Island Tinkers, Innovation and Transformation in the Making of Taiwan's Computer Industry. And she is a historian of technology and an assistant professor in the Electrical and Computer Engineering Department at the University of Minnesota, Twin Cities. And she's also associated with the program in the History of Science, Technology, and Medicine at the University of Minnesota. And also a recipient of the 2025 to 2027 McKnight Land Grant Professorship. Honghong is also a graduate of Cornell's Science and Technology Studies Department, where she and I both received our PhDs. So please welcome Honghong Tinn.
Thank you.
Okay, so to start off, we are going to start off with a poll. And so actually, before we start with the slider poll, I want to see sort of just a show of hands. Who of you in the audience is from Taiwan or has a parent or grandparent from Taiwan? Okay, pretty good, not bad. And our first word cloud question. When you hear Taiwan and technology, what is the first word or company that comes to mind? Okay. Overwhelmingly, we see TSMC as the answer to that. And I see also Foxconn, Chips, Railroad, Boba. Okay, Boba is very good. Silicon. Proud, that's good. Texas Instruments, okay, that's interesting. Taiwan and, okay, I see China and I see fabs. Okay, so TSMC, so I just looked this up today. TSMC is by far the largest company in Taiwan by market capitalization at the moment, $1.5 trillion. And the next largest company is Foxconn, and it's way down at like 3 billion or so. So it's, or actually no, more like Anyway, you can look it up. So it's an order of magnitude difference between TSMC and the next largest company in Taiwan. So that kind of tracks. Okay, so the next question, does made in Taiwan connote a quality product to you? Wow, okay, all right. Right, started at 87%, now we're down to 76%. Okay, no is trending up to 7%, okay. Not sure at 20%. Okay, no is down to 6%. Okay, we're stabilizing at about 71% yes, 6% no, and 23% not sure. Okay, interesting results, great. I'm sure in the 1960s that would have been a very different answer. Okay, our last Slido poll. How many of you are concerned about Taiwan's role in the computer industry's supply chain? Okay, starting at 100%. All right, down to 96, okay, 90% yes. Okay, all right, shaking up. Okay, so right now, yes is stabilizing at 78%, no at 11%, 10%, not sure at 11%. Okay, all right, oh, interesting results. I probably would have expected those results. Okay, so let's start with, Honghong, you and I both went to graduate school in the Science and Technology Studies department at Cornell, and so I've seen the beginnings of this project from way back, the very beginning. So just start with, how did you come to this project? How did you start this?
Yeah, sure. So I was one of the island tinkerers in my book. I built my own computers when I was in college. And so in Taiwan, some of our audience, or perhaps Hansen, you know that it is relatively easy to do so. You just walk into a big mall, a super department store, and you see hundreds of shops that sells electronics products. So you can pick up your own motherboard, memory card, sound card, case. You choose the color you like, right? And then the monitors, and then you can bring them home and build your own computers. And so when I started my PhD studies, I wanted to work on a dissertation on that, and I worked with my advisor, Ron Klein, who was also on Hansen's committee, and he is a historian, so he told me let's historicize the topic. And so I started looking at the Taiwanese history to see if anybody was building their own computers in the 60s, 70s, and 80s. So that was the start of my book project.
All right, thank you. So I also want to mention, so another personal connection that I have to this story is that when I was in third grade, my family moved back to Taiwan, where my dad took a biotech job in a city called Hsinchu. And Hsinchu is actually where the government created a science technology park. And so that was 1985. I was in the third grade, and that was 2 years before TSMC was founded there. And so the reason why Hsinchu is sort of today thought of as the Silicon Valley of Taiwan, there's a similar reason to Silicon Valley here. Stanford was a crucial reason why Silicon Valley is here. Similarly, in Taiwan, the Hsinchu is a location of National Chiao-Tung University, right? So can you tell us how important National Chiao-Tung University was in starting the computer industry in Taiwan, and also the role of the Chiao-Tung alumni and their connections both in Taiwan and US alumni?
Sure. So I started my book with several chapters about National Chiao-Tung University, and that's because the first two available mainframe computers available in Taiwan were installed there, and it was in Taiwan because of a United Nations technical aid program. And the program brought the computer and also brought visiting professors to teach electrical and computer engineering courses there, and it also brought funds to support some kind of training classes, and that all together trained the first generation computer engineers, computer programmers, and computer users. And that's why that kind of, to me, that was the kind of foundation of the computer industry in Taiwan. And the second question is about the alumni. I know we probably have some Cornell University alumni here or University of Minnesota alumni today, so I probably can take a little bit, like a longer time to talk about alumni stories. So Chiao-Tung University was a really good and prominent engineering university in China before World War II. It was founded in 1896. It was a public university. For a while, you can see English newspapers dubbed Chiao-Tung University as the MIT of the Orient. And so during World War II, actually after World War II, because the Communist Party defeated the Nationalist Party in China, so the Nationalist Party leader Chiang Kai-shek decided to move to Taiwan. So 1.2 million civilians and soldiers followed Chiang Kai-shek to Taiwan and resettled there, started their new life there. And among the 1.2 million civilians and soldiers, 1,000 of them were Chiao-Tung alumni. So they become kind of prominent engineers, technocrats in Taiwan. And some of them moved from the United States to Japan and United States, and then Southeast Asia. So those alumni in Taiwan started to have their kind of annual reunion, sort of homecoming event, but their alma mater was not in Taiwan. So in the beginning, they thought there was an opportunity for them to go back to China to visit their alma mater again soon, if Chiang Kai-shek were to retake mainland China soon. But as time goes by, they realized that this was not going to happen. So they started to work together to kind of lobby the Taiwanese government to reopen the Chiao-Tung University in Taiwan. So long story short, they reopened the university successfully in around 1957. And during the lobbying process, the US alumni and the Taiwanese alumni would write to each other and toss ideas to find out ways to persuade the government to support their kind of efforts, and then to think about who would be a good visiting professors that they can bring from the United States to Taiwan to teach new courses, and to talk about donations of money and equipment to help the new generation of engineers, undergraduate generation, to learn the latest electrical and computer engineering expertise. So that was how they kind of worked together to refund the university in Taiwan.
Thank you. And I guess I just want to give a little bit more context. So the government of Taiwan is still officially known as the Republic of China, or ROC, officially. So when we say the Taiwanese government, we're talking about the ROC government. And so I guess you already talked about the importance of the foreign aid programs. How did the government, the ROC government, think computers could help with the building up the economy and the military readiness of Taiwan?
Yeah, so in my book, I'm trying to tell a story from the alumni's perspective. And so they kind of persuade the government to emphasize computers overall and their contribution to economies and militaries. And when they were trying to lobby the government, they emphasized two types of discourses. And both of them were kind of Cold War related. First of all, they emphasized that the studies of electronics is similar to the study of atoms. So they are trying to argue that the studies of electrical engineering is as important as the studies of nuclear energy. So if Chiang Kai-shek government was interested in nuclear energy, which was a big thing in 50s and 60s, then they should pay attention to electrical engineering. So that's first type of discourse. The second type of discourse is about this possibility of a hot war during the Cold War, right? So people in Taiwan in the 50s would be worrying about a possible outbreak of a war. And Chiao-Tung University alumni would talk about their World War II contribution. In China, they would be the group of engineers who were maintaining the infrastructure during the wartime in China, the railways, telecommunications, telephone systems, water, utilities, so on and so forth. So they try to kind of ask the government to consider if there could be a war in the future, then you probably want to train more engineers, and Chiao-Tung University should be reopened in Taiwan. So that was kind of how they persuaded the government by emphasizing their importance in these two aspects.
Mm-hmm. Thank you. And did U.S. military assistance to Taiwan impede or help development of a native computer manufacturing capability?
Yeah, so I have a chapter about U.S. military aid to Taiwan, which was lasting from 1950 to 1978. And so the typical story in the United States is that the military funding was a very important part of the development of digital electronic computers in the United States. So hence we have this military industrial academic complex. In the United States, the three sectors grow together and people move around the three sectors, and expertise circulated around the three sectors. So this is a typical kind of textbook story we will read in graduate school. But when I was looking at my case, I realized I didn't really see military stories in my case. And it looks like Chiao-Tung University was ahead of the military in terms of using computers. They had the first two computers around 1962, 1964. But for the Taiwanese military, they didn't have a computer until a later time period. It was more like late 1960s. And so I looked into the materials and I realized in the 50s, Taiwanese military didn't really have the incentives to do fundamental research on computing devices. They were not quite interested in building a computer like other countries would like to do. And that's because the kind of very generous US military aid to Taiwan at that time would grant or sell Taiwan this bundled large weaponry systems. And in these bundled large weaponry systems, computer is only one part of the components. And so they just need to learn how to use it. And so they didn't really have to kind of reinvent the wheel. And so in the 50s, that was not really a kind of a factor to encourage Taiwanese military to do research on that, because they did have the product to be used at that time. But later in the late 60s and 70s, there were more military kind of type of research and applications in computer fields, and the stories in Taiwan is gradually kind of moving onto kind of more the American model here.
Mm-hmm. And you did mention some of the earliest computers that were sent to Taiwan, were operational in Taiwan, and these were IBM computers, correct? Mm-hmm. Can you tell us which models they were?
Yeah, so the first one was IBM 650, and it was installed in 1962. The second one is IBM 1620, and it was installed in 1964. If you have been to the IBM 1401 room downstairs or this direction, they look really similar to each other.
And they were both at Chiao-Tung?
Yeah, they were both at Chiao-Tung University, yeah.
Okay. And can you discuss the first attempts by university students to build their own computers in Taiwan?
Yeah, so this is my chapter 5. And so I talk about 3 groups of graduate students and undergraduate students. built their own mini computers and calculators from scratch, and they did that respectively 3 different projects. And they were thinking about if they could kind of do a prototype, maybe they can learn how to mass manufacture them in the future. So they had that type of application in mind when they started this kind of exploring experiences. And I think the most remarkable part of that, those projects were, it was not easy for them to do so, because a lot of parts were not available in Taiwan, so they had to kind of source recycled items to put together a computer, or they had to work with factories in Taiwan to custom-made some components for the computers. And sometimes they had to kind of import expensive parts from overseas in order to build their mini computer and the calculator. And so that was my chapter 3. Yeah.
And so why did they try to build a mini computer rather than like a mainframe or some other type of computer?
So that was the time when mini computer became available, and mainframe computers are difficult to build in part because of the presence of IBM, right? Because the components and everything is dominated by this tech giant at that time. Mini computers is smaller. So it's more possible to maneuver. And then there were some parts available for them to start thinking about that.
Right. And what important people came out of these projects?
Yeah, so one of the most important people in that chapter is Barry Lam. Barry Park Lee Lam is his full name. In Taiwan, he's also known as Lin Bai Li. He's the founder of Quanta Computer. He's ranked the 192nd richest person in the world. And so I wrote about him because in 1972, he built a mini computer from scratch, and then he wrote his master thesis on that, about the architecture of that, programming part of that. And so he was born in Hong Kong, and then, he was born in China, grew up in Hong Kong, but he went to National Taiwan University for undergraduate and master's degree. And after he built the mini computer, and then he worked for a startup company to make calculators for export market. And then he moved to a couple of different startup companies, mostly calculator builders, and then later computer manufacturers. He finally founded his own company in 1988. So nowadays, Quanta Computer is a leading manufacturer of laptops and servers. And so for the servers market, Quanta Computer is the 3rd largest manufacturer in the world. It has 17% of the market share. And then for laptops, the number in 2020, 1 out of every 3 laptops produced in the world was made by Quanta Computer, because it's a subcontractor. So sometimes you probably bought a computer that doesn't really say Quanta, but was actually manufactured by Quanta. And so Barry Lam is really a tinkerer in my book. And thanks to the oral history interview conducted by Dr. Lin Fei Lin and deposited at Computer History Museum, in that interview, oral history interview with Computer History Museum, he mentioned that he was the best person in his company around 1972 to solder parts and to build the calculator. Sometimes he was the designer, he was an engineer, but sometimes when the order is kind of rushed, he had to stay up late and build the calculators with everybody else. And he said he was so good with doing that. So he was a true tinkerer.
Great. And can you discuss how Taiwan became an important electronics components manufacturer and location for US and European companies? And these include CRTs, TVs, radios, transistors, IC packaging, magnetic core memory, and other components.
Yeah, so around the mid-1960s, the Taiwanese government decided to build a few export processing zones. And in these areas, multinational corporations are encouraged to set up electronics manufacturing factories in Taiwan to enjoy some tax breaks and to have the privilege to use the inexpensive labor in Taiwan at that time. And so some American companies or European companies and Japanese companies decided to set up a factory in those areas. For example, Wang Laboratory set up a factory there, and the Dutch multinational corporation Philips set up a subsidiary factory there. And General Instrument, an American company, set up a factory there. Philco Ford, which is the IC company at that time, set up a factory there too. And Taiwan's labor cost was slightly lower than Hong Kong. So by then, Control Data Corporation had a factory in Hong Kong. Fairchild had a factory in Hong Kong. But some other US companies decided to choose Taiwan and set up factories there. And in terms of the products they make, it could be factory workers, again, welding or soldering an IC chip onto a platform. So that's part of the IC packaging. Or they could be assembly transistorized radio, black and white TV. And I think the most interesting product among all the possible products I have seen in the archives is the magnetic core memory units. And that's a type of computer memory that was popular in the 1950s, 60s, and sometimes into 70s. And if you are a museum goer, then you can see some of them downstairs. So basically, women factory workers, mostly women, would weaver a copper wire into a magnetic core. So they are actually weaving a cloth to create this computer memory units. And they sometimes have to do that under a microscope.
Right, and you mentioned you have a whole chapter on the important role of women workers. So they weren't just doing the core memory, right? They were also doing, creating a lot of these other components as well.
Yeah, so I really like that chapter, and I'm trying to say that among all the tinkerers that I have mentioned so far, we should remember that women factory workers were also one of the tinkerers. They contributed a lot to use their skills to create good quality products in Taiwan. And so I actually named that chapter as Women's Memories, Men's Factories. And so there are kind of three layers of connotation of memories here. First of all, they made magnetic core memory among all the products they made. And secondly, in some primary sources, I see some women factory workers talked about they really want to do well in their work. And the trick to do well in their work is to think of themselves as a computer. So you memorize everything you have done and memorize every mistakes you have done before and try not to repeat it. So they kind of internalized this cyborg type of discourse in 1960s. And it's factory workers, not really college educated students. So it was really amazing. And the third connotation of memories refers to the career path. So I compare a lot of career paths of maintenance and equipment engineers, usually men with college degree from possibly Chiao-Tung University, with the career paths with factory women workers. And I found that a lot of this equipment engineers, quality control engineers, maintenance engineers, were able to enjoy some entrepreneur opportunities in later parts of their career, in later part of their life. But for women factory workers, they stay in the factory for a long time, in and out, because sometimes they got laid off. And so factory to them is really a memory over there, not something material they own. So that's a chapter about the factories, about women workers and engineers.
Thank you. So earlier when you were talking about Barry Lam, you mentioned that he started off with a company making calculators.
Yeah.
And so can you talk about the importance of the calculator industry in particular in really setting the stage for the later computer industry, and also, you know, some of the other people that came out of that calculator industry?
Yeah, so by 1972, it was possible for someone around the world to use $200 to buy a microprocessor from a company in the United States and build a calculator. So it creates a lot of entrepreneur opportunities around the world. And Taiwan had several startup companies decided to make calculators around 1972. They competed with each other fiercely. And by 1978, 20% of the calculators manufactured was manufactured by a Taiwanese companies in general. So Taiwanese companies enjoyed 20% of the market share of calculators in 1978. So I can share with you two examples. So Barry Lam was the first one, right? So he was building a calculator in school in 1972 and worked for a calculator startup soon after that, and he founded his own company to make laptops in 1988. And another example is Acer Computers founder Stan Shi. So in 1972, he was hired by a company to make the first domestically manufactured calculator. And he and 7 other Chiao-Tung University engineers worked together to create that calculator for export market. And he founded Multitech, in 1976, and the company renamed itself into Acer in 1987. So that's the two prominent example of starting with a calculator maker and later become a computer manufacturer.
Great. So how did they transition from calculators to computers?
So it's about, so you got to have a microprocessor and you have to program it, and then you need to have the case to do it, and keyboards, so on and so forth. And so by 1980s, you can still use $100 to buy some really good chips to build your own computers. So Stan Shi started to make the first microprocessor trainer in 1978. And then the second computer he rolled out was microprocessor Model 1. That was 1981, and the microprocessor Model 2, which you were able to see in the reception room, was rolled out in 1982.
And so a whole chapter of your book talks about the microprocessor 2 and what happened when Multitech tried to sell it in the United States. And Apple's reaction to that. And so could you tell that story?
Yeah, so in the early 1980s, if you are a startup company and trying to make computers, you have roughly 3 options. First of all, you can create a one-of-its-kind computer and try to find out your consumers. And secondly, you can choose to make an Apple or IBM compatible computers. And third, you can try to do, make a knockoff version, clone version, or be a counterfeiter, right? And then Stan Shi in 1982 decided that he was going to go for the compatible computer option. And he worked with his engineer, try to make sure they were not going to infringe any copyright issues at that time. And
So is that the difference between, because you mentioned the compatible versus counterfeit. What is exactly the difference?
counterfeit is an entire clone of another thing, right? But compatible is trying to make sure the products can run the similar products that can be used for Apple computers or IBM computers. But in 2025, today, we know that Apple doesn't allow any compatible computers. There are not supposedly to be, there are not supposedly to have like a Apple compatible tablets in the market, right? Because they don't allow that. So their strategy in the 1980s was to sue the companies that make compatible computers to make a case. So in the United States, the famous case is Franklin Computer Corporation. Apple brought up a lawsuit in 1982, and they settled in 1984. Since then, Franklin Computer Corporation were not allowed to make any compatible computers. And but for countries beyond the United States, Apple could kind of bring up lawsuits in different countries. But Apple also worked closely with this US Customs to stop any counterfeits or compatible computers to enter the US territory. And so Apple's reasoning was this is unfair foreign trade practices. And to respond to this kind of reasoning, the US Congress formed a committee and held several kind of congressional hearings. So my chapter 8 was about the representations of Taiwanese computer makers around this time in the congressional hearings and also in kind of mainstream media. And I had kind of two observations. The first observation was that all the Taiwanese computer makers were lumped into this big category, counterfeiters and invaders. So people didn't really care about that boundary between counterfeiters and compatible computers. And my second observation was about this misinformation about Taiwanese computer makers around that time. And when I was looking at the archival documents, I see a lot of kind of inaccurate information about Taiwanese computer companies would be placed with the truthful information about these companies. So nowadays we call it fake news, right? And I saw a lot of type of kind of portray of Taiwanese companies at that time in the primary sources. I can share a brief example today with you. So Life magazine sent journalists and photographers to visit a Taiwanese keyboard manufacturer. And that was in March 1984. So they visited this keyboard factory and took pictures of the keyboard designers and the staff members there. Everybody looked very happy on the photo. And so the keyboard engineer was looking forward to see the published news article. A couple of months later, in September 1984, he saw the published magazine and he realized that his photo is placed in a news article titled "The Booming Business of Counterfeit Goods in Taiwan." And along with his keyboard photos, there were Cabbage Patch Kids, fake ones that the Life magazine journalist found in Taiwan, and also fake Ray-Ban sunglasses that they found in Taiwan. And so the keyboard designer was really upset, so he reached out to Taiwanese media for help, and he tried to clarify that he was not a counterfeiter. Because if he would have been one, he wouldn't really allow the Life magazine people to take photo of him. And he actually had his name engraved on the IC chips everywhere inside of the keyboard. So he was really kind of designing everything from scratch. So this was a chapter about kind of orientalization, stereotyping of Taiwanese computer makers in the early 80s.
Mm-hmm. And I mean, the microprocessor 2 itself, how did Multitech, that was not, it's not just a ripoff, right? There's actually original engineering being done on that computer.
Yeah, so from the available resources that I was able to kind of read and access biographies and oral history interviews here, Shi emphasized that he really wanted to not to be a counterfeiter since the beginning, because he was the franchisor of Texas Instruments, Zilog, Intel. So he really wanted to maintain a good relationship with his US trade partners. So he wanted to have compatible computers because that's where the market is. So he worked with his engineer to make sure they are not copying Apple. And so that was really like what he determined to do in the first place. But overall, to be compatible with other products, at that time, there was no clean room practices. So possibly they were exposed to some codes written in Apple's like a firmware or software, so on and so forth.
Right, so Apple still had a claim for copyright infringement.
Yeah, however, Apple has never sued Acer in Taiwan. Mm-hmm. Apple brought up lawsuits against a couple companies, but not Acer.
Right. Mm-hmm. But the microprocessor 2 did have an original operating system, mm-hmm. and also it had a feature that Apple IIs in the US did not have.
Which is to display Chinese characters. Mm-hmm. Yeah.
Okay, but then of course, the IBM clone market was very different from the Apple II clone market. So what happened there?
Yeah, so IBM allowed compatible computers. Therefore, companies such as Compaq was doing a lot of IBM compatibles. And Acer also switched to IBM compatibles in 1983 immediately, in the middle of the lawsuits between Franklin and Apple. So IBM allowed everybody to do that until 1987. IBM decided to charge everybody royalties for the patents and everything related to licensing, so on and so forth. And so IBM had kind of negotiation with the attorneys of each company to negotiate the rate they were supposed to pay IBM, and they traced the royalty back to 1983. So in terms of the stereotyping, I found a lot of kind of primary sources talking about like Taiwanese companies are like flies that wouldn't go away in terms of copying IBM's compatibles. Yeah.
But despite all of these concerns, how did US companies begin to trust Taiwanese companies as contract manufacturers, especially for laptops?
Yeah, so I think to me, the turning point was actually in 1986. The computer makers around the world were competing with each other to come up with the first 30-bit IBM compatible computers. And IBM worked really hard on doing that. But the first one that came up with 30-bit,
32-bit?
32-bit computer was Compaq computer.
That's the 386.
Yeah. And then the second company that was able to do that was Acer. So that was the turning point that Acer kind of demonstrated the really good kind of accomplishment in technical arrangements and manufacturing capabilities and a little bit kind of marketing skills, and for Acer to kind of become sought after manufacturers. Mm-hmm.
I mean, earlier you mentioned, the number of, Quanta's dominance in laptops. Over time, from the 90s to 2000 to today, how many of the world's computers, percentage-wise, has been manufactured by Taiwan?
Yeah, so for laptops, I have one number around 2010, 2011, 90% of the laptops were manufactured by Taiwanese companies. And for desktops, around the same time, 2011, 2010, Acer has 14% share of the world market. Asus had 5.5% share of the world market in that year. If we are looking at the year for last year, Acer and Asus, each of them has 7% of the market share. Mm-hmm. So, but if we are talking about components, the computer parts that are made in Taiwan will be much higher than this number. In the beginning of my book, I used the example of the 1999 earthquake. So on September 21st, 1999, in the midnight in Taiwan, there was a huge earthquake. Eventually, it killed around 2,000 people, and there was a lot of power shortage, water shortage. And it was daytime in the United States. So by the evening time, CNN interviewed Steve Jobs, who just returned to Apple, to ask him to comment on this potential impact of this earthquake to the supply chain of computer parts in the United States and globally. And Steve Jobs was like, I'm not so sure, but we are sure a lot of parts are from Taiwan, so there will be certainly certain type of impact. So for that year, there was a huge delay for computer parts for people to build computers to sell.
Mm-hmm. And you mentioned Asus. Could you talk a little bit more about that company and especially Johnny Shi, who originally came from Multitech?
Yeah, so I only just briefly talk about that, but I feel that Asus is a really good example of the motherboard making manufacturers in Taiwan. It was kind of one of the best one of the largest one, and it also reflects the huge motherboard manufacturers in Taiwan at that time, 1980s, late 1980s. And so Johnny Shi, one of the major kind of top people in Asus was Acer chief R&D engineer. So the 32-bit compatible, IBM compatible computers was really possible because of his leadership.
And he had worked on the microprocessor too, correct?
Yes, I think so, yes.
Yeah. So what do you think about, so Apple computers often say designed in California and assembled in China or assembled in Taiwan. So what do you think of that characterization?
Yeah, so assembly to assemble is a really oversimplified term. It actually contains a lot of different activities on the other side of the Pacific. You need to have a very skilled labor to put together things. You need to have a very good quality control managers to really make sure everything is assembled properly. And also you need to have top quality equipment maintenance engineers to work on the machinery to make sure things can run well in a factory, right? And also Taiwan, in the history of Taiwan, I've seen a lot of discussion about automation of assembly since the 1970s. And so there's just a lot of things going on in the assembly part, and it's a really complicated term. And yeah, so this is really a $1 million question. My 2 cents from my book is the tinkering activities is really important. The long history of the computer development, computer industry expansion in Taiwan seems to be able to kind of attribute to this reoccurring pattern that Taiwanese universities, factories, startups, and even the kind of hobbyist culture were really interested in engaging with the hardwares and tinkering with the technology, the materiality of technology.
Excellent. So let's pivot and talk about TSMC. So how has Taiwan managed to become the world's leader in leading node microchip fabrication? And how important was government support in making that happen?
Yeah, so in my book, I'm trying to say that government support was important. But in addition to that, you need some non-government factors to work with it, government together to make that happen. And so today I can share like those type of non-government factors. So first of all, Morris Chang, the founder of TSMC, was a really important asset to really realize that dedicated foundry model idea in Taiwan. And secondly, when Morris Chang was raising the startup money for the newly established TSMC, the Dutch multinational Philips contributed a significant amount of money to make it happen. So I will start with Morris Chang. So these are all non-government factors, work with the government support. So Morris Chang was born in China in 1931. His family moved to Hong Kong in 1948, and then he moved to United States for undergraduate and graduate degree. He left MIT in 1955 with an undergrad and master's degree in mechanical engineering. So he worked for Sylvania after graduation for 3 years, and after that he worked for Texas Instruments. So he worked there for 25 years and he did so well there. So if you look at the annual report of Texas Instruments in the 70s and in the 80s, his name is on the back of the annual report of the corporation. He was one of the vice presidents. But by 1980s, he felt like he reached the ceiling of the promotion. So he decided to take this job offer from Taiwan, to move to Taiwan. And then when he moved to Taiwan to lead a research institute, Taiwanese technocrats asked him to come up with a business plan to start a new company, any type of company. But this company has to kind of stimulate the economic growth in Taiwan or to push the technology industry a little bit in Taiwan. So Morris Chang toast this dedicated foundry model idea, and the technocrat says, yes, no problem. They are all Chiao-Tung alums. And so Morris Chang's experiences at Texas Instruments was really important to make the TSMC possible in Taiwan. And so let's move to the Philips part. So Morris Chang was, he needed $200 million to set up TSMC. He was able to raise 75% of the money from the government support. So the government technocrats persuaded some enterprises and banks to invest in TSMC, but he was not able to secure the last 1/4 of the money, that's $50 million. So he even briefed at Intel and Texas Instruments, and he said, they allow me to give a briefing just out of courtesy. They were not interested in this foundry model at all, because at that time, this dedicated foundry model was just really not making sense. And so eventually, it was the Dutch multinational corporation, Philips, contribute $50 million, the 25% of the startup money, to allow TSMC to really kind of incorporate it. And the reason they were willing to contribute was because Philips set up a factory in Taiwan in 1967, made IC packaging, magnetic core memories, TVs, so on and so forth. And the chief manager of Philips subsidiary in Taiwan wanted to do IC wafer making in 70s. This was his dream, but he would write proposals to the Dutch headquarters and ask them, if we do very well in IC packaging, let us do IC wafer manufacturing. But Dutch headquarters were not interested in transferring that type of section of manufacturing to Taiwan. So when he realized Morris Chang was raising money to do IC wafer manufacturing, he was so happy to help to persuade Dutch headquarters to do that. So in my book, I'm trying trying to argue that the success of TSMC was really about this existing infrastructure, manufacturing infrastructure in Taiwan, and the booming of computer manufacturing industry in Taiwan.
Mm-hmm. And talk about some of the most important decisions that Morris Chang and the other leaders of TSMC have made to make them successful.
Yeah, so I think maybe we can kind of think of, what I can think of would be 3 companies that were really either important suppliers or important business client of TSMC kind of grow together with TSMC. So the first one is ASML. So ASML is a Dutch company, and it was a spin-off of Philips. So when ASML was founded in 1984 and TSMC was founded in 1987, they two naturally kind of worked together. And so ASML supplied the lithograph machines for TSMC to make IC wafers. And so that's the first company that I can think of right now. And the second one would be NVIDIA. So when Morris Chang toast this idea, dedicated foundry model, but Intel and Texas Instruments were not interested, that was because at this time, everything was made by integrated device manufacturers. So IBM, Texas Instruments, Intel, they would design ICs and then make IC in their in-house fabrication facilities. And so when Morris Chang proposed this idea, there were not really many IC design houses, so the demand was not there. And so NVIDIA and other IC design companies only emerged in early 1990s. So NVIDIA was founded in 1993, and so by 1995, 1996, 60% of the revenue of TSMC was from IC design houses. And so NVIDIA started to work with TSMC in 1998. So they grew together, helped each other to grow. So to quote Jason Huang's term, he said that was a really win-win situation for them. And the third company or the business decisions that you were talking about would be about Apple's iPhones. So TSMC was so interested in making chips for iPhones. And so finally, they were able to do that in 2014 for iPhone 6s. And so that was really an important turning point, again, for TSMC. TSMC was doing very well before that, but because of the Apple as the business client was really help TSMC to grow a lot too. So in 2017, Morris Chang decided to retire, and he had a press conference, and a journalist in Taiwan asked him, like, what would be the most proud thing that you have done in your career? And Morris Chang think for 2 seconds, and then he said his contribution to TSMC was really to push the advances of smartphones. So as a manufacturer, he was really having this kind of pride about allowing the revolution of smartphone to happen.
Thank you. So we're going to switch over to audience questions now. And, okay, so let's see. All right. So do you think China will make its move as soon as Western countries will be able to secure a stable alternative supply chain, e.g. the Arizona TSMC subsidiary?
So my book was really more about Taiwan. So I probably can kind of make a useless prediction of Taiwanese historical actors. So I think the supply chain is really a global thing, right? So if you are are able to control one part of it, the rest of the supply kind of components needs to cooperate too. So I think after Pelosi visited Taiwan, the then CEO of TSMC, Mark Liu, was interviewed by 60 Minutes, I believe. And then he said, even if someone controls TSMC's factory, that entity will not be able to control or really make wafers because you just need a lot of components, suppliers to work together to really make the IC wafer. So that type of kind of control might not be useful.
And so what are today's tinkers working on in Taiwan? AI, quantum, energy?
Yeah, so I think there is still a very kind of fascinating computer tinkering culture. For example, there was a really famous influencer visit Taiwan twice. I think the channel's name is Linus Tech Tip. So he basically went to Taiwan and he went to those super department stores of electronic parts and he put together really powerful, fancy computers, desktop computers for gaming majorly, or you can mine Bitcoins by putting a stronger computer by yourself, and he would gift it to a fan that recognized him on the street. So those YouTube videos went viral in Taiwan for a while. So there is still a very vibrant tinkering culture in terms of computers. And recently, I've seen people sharing with me about the kind of alternative energy. So for example, if you have to build a wind turbine by the seashore, you need a lot of kind of constructions going on at the shore to make it happen. And so the author of Why Taiwan Matters, Shirley Rigger, wrote me an email a couple of days ago to talk about she likes the tinkering ideas, and she recently visited a company who made that foundation work in Taiwan, and she feels that this was really a tinkering process to learn how to move on to another field and then to kind of realize the plan. And that's kind of a tinkering process she observed. And definitely, this is on the alternative energy part of it.
In your opinion, why is Taiwan's tech industry so focused on hardware while software appears to be a missed opportunity?
Oh yeah, so I don't really cover software history in my book, and there aren't many kind of materials that I was able to access to. But I feel like there were actually a lot of efforts in terms of doing programming in the 60s and 70s, because at that time you really just need to write your own codes to make the computer to run, right? So I believe there are some kind of practices there. It was just not in my book. Yeah, but overall, I think software industry in Taiwan is not as strong as the hardware industry, but Taiwan's companies seems to be doing okay with like IC design overall, yeah.
So a lot of countries have tried to replicate Silicon Valley, Silicon Alley, Silicon Gulch, et cetera. Why has Taiwan succeeded when others have failed?
Yeah, so again, this is the $1 million question. And I feel like the Hsinchu Science Park was probably not entirely a replica of Silicon Valley, and the history of Silicon Valley was probably more organically formed. Therefore, Taiwan was able to succeed in part because of the engineering education there, and National Chiao-Tung University was really one of the many examples over there. And because the Cold War situation really encouraged Taiwanese engineers, technocrats, and computer users to tinker with technology. For example, the two computers that I mentioned in the beginning, it took a couple months for the computers to arrive to the island, right? And so these imported technologies were really precious, and then once they have an opportunity to have access to the hardware, open the black box would be a very important part of the learning process. And so I think that combined with the engineering education and a very vibrant entrepreneur culture starting in 70s because of the calculator boom, and that all together really organically and also kind of contingently to allow companies to develop as a network, clusters to work together. Yeah, so I think that's really, there probably is no formula to really kind of toast some ingredients and create a Silicon Valley. It really requires to have some aspirational engineers to make that happen. So in 1990s, when those new personal computers promoted and marketed by Stanshi, the name of those computers were Aspire. And I found that kind of, the term to be kind of aspirational and to aspire was part of the tinkering kind of mentality over there.
Mm-hmm. And so what lessons about industrial policy can the US learn from Taiwan?
Yeah, so in my in the TSMC chapter, again, I felt that it was really not only the government policies, although the governments, the technocrats in Taiwan at that time was definitely very dedicated and really want to make something to happen. So in the current history writing, a lot of people will attribute to this leadership by them. Especially they created the export processing zones that I talked about. They were willing to found the reopening the Chiao-Tung University. They found the Hsinchu Science Park in 1970s. And so I think those are really good decisions they made to make that happen. But again, I feel like the tinkering culture of that, engineering's interest in bringing new technologies to the society, to manufacture things locally, to explore the black box would be a very important part of it.
Mm-hmm. So what was the attitude in Taiwan of engineers who decided to emigrate to the US rather than stay and build up Taiwan's own industry? And you mentioned in the book, the abnormal club, which kind of hints at the idea that staying in Taiwan is abnormal.
Yeah, so this is a group of people in National Chiao-Tung University that they decided to get together and then they named themselves as Abnormal Club because the normality at that time would be getting an undergraduate degree and then apply for PhD degree in the United States or master degree in the United States. And then that will be kind of opportunity for them to get a better job and for them to be away from the Cold War atmosphere in Taiwan, right? And so several of my historical actors in the book were from this club, and they were really interested in staying in Taiwan and contribute what they have learned from the university to the industry or in academia. And of course, there seems to be a division between people who make different life choices. However, in the later time period, the alumni in the United States, the network in the United States also worked closely with the Taiwanese engineers, entrepreneurs, and business people. And so a lot of investment of the Hsinchu Science Park in the first few years were really done by US Taiwanese Americans. For example, UMC, the United Microelectronics Corporation, was one of the early foundry companies in Taiwan. It was founded in 1980s before TSMC, but the scale was smaller. And they were trying to make more wafers at that time because a lot of Asian American engineers decided to start a new company in Taiwan, and they need some people to make ICs for them. So that was really a lot of kind of cross-Pacific collaborations, money, people move around, technologies, expertise move around. So I think there's a very famous book on this in terms of Taiwanese Americans' contribution to the Silicon Valley, and it's written by a UC Berkeley professor, Saxenia.
Annalise Saxenian?
Yeah.
Saxenian. Right, she's the author of the
Regional Advantages,
Yeah, right.
And another one.
Right,
and,
that one's about.
And both are all about Taiwanese Americans' contribution to Silicon Valley.
Right, and then comparing Silicon Valley to Massachusetts, Route 128. Okay, so what is the Taiwanese focus right now in terms of what is the next generation technology?
I don't know yet, but I think manufacturing is still a big part, and there is a lot of AI boom discussions, so the demand for AI chips still is on TV news headlines all the time. So I think that is still something a lot of companies are betting in right now.
Okay. And what was special about technocratic policymakers in Taiwan that made them effective in shaping the tech industry? And also, why are today's politicians unable to do the same?
Oh yeah, so I think a lot of technocrats during the Cold War era, 1960s, 70s, were really interested in increasing so-called foreign investment in Taiwan, and there were a lot of plannings going on. But nowadays, the planning, I bet there are some sort of planning going on, but the society is more democratic, so people can really comment on the government's policies, so on and so forth. So perhaps it's not as quote unquote efficient as it used to be in a more authoritarian state. But in a democratic society, people enjoy more freedom, so that's really nice for the people who live in a democratic society, I would say. So this is really just my rough kind of categorization of the two time periods. And yeah, so I think technocrats can refer to a very negatively kind of type of connotation over there too. So, because it's kind of like they get to decide a lot of things over there, and yeah, so I'm not so sure. I feel like maybe like in Cold War time periods, governments has more powers, right?
Why did Taiwan not go into the memory business, like the semiconductor memory business, like Samsung or Hynix?
Yeah, so Acer decided to went into DRAM business in 1987-ish. And the reason Stanshi wanted to do that was because for a computer maker, he sometimes had a lot of problem to secure DRAMs for his own Acer computers. So he thought maybe I should just have a factory myself. So he invested in a DRAM facility, and it was a collaboration between Texas Instruments and Acer. And Morris Chang was actually the person who went to give a briefing at Texas Instruments with Stanshi. So he helped setting up this DRAM facility in Taiwan. However, from Morris Chang's perspective, of course, retrospectively speaking, semiconductor industry is a very fluctuating market, and he was in Texas Instruments from 1958 to 1983, 84. So he has seen that fluctuation a lot, and he didn't think DRAM would be a viable option in the 1980s Taiwan. So he went for the dedicated foundry model.
Right, I mean, Intel famously got out of the DRAM business, so. Yeah. Okay, one last question. We're at time, but I do want to ask one last question. So why did Foxconn build large factories in China, mainland China, instead of Taiwan?
Yeah, so the short answer would be the labor, right? And so, Terry Guo, the founder of Foxconn, started to build a lot of kind of electronic components, including the computer game joysticks. And that was in 1970s, late 1970s. So he set up factories in in China since the beginning, when people were allowed to do so. And so his company grew and expanded kind of aggressively in China. So that was really kind of, I feel like that was more like the kind of the attraction of inexpensive labor at that time, accessibility to lands, and of course he has a really good business skills to get good orders and business opportunities from a lot of Western companies. Mm-hmm. So.
Well, thank you very much. We're at time, and thank you all for coming. And pass it on to Mark.
Thank you, Hong. Thank you, Hanson.
Thank you.
Wow, what a great talk. And I really feel this is what CHM does so well. We tell you stories about the past so that we can understand what's happening right now. Thank you so much. Please support the museum, and safe travels home. Thank you.